Alright, this is the third question I have for us today, and you can see it is a theory question from 2006, number 13B. And the question they gave us a sketch, so this is just a guide on how your diagram is going to be. But I don't really need this diagram. I want us to focus on this statement. The statement is very important. It's good for you to be able to solve question on bearing. You should be able to draw your diagram correctly, even without seeing a diagram from the question, because you can't see what they will ask. They can give you a question without drawing it, so you should be able to draw it yourself and locate all the points correctly with the right bearing and do your calculation. Okay, so this question, let's start together. It says the diagram shows the positions of 3 points x, y, and z on a horizontal plane. So I told you before, when we talk of horizontal plane, we are talking about a level ground where you can locate 3 points on the ground. So just like this flat screen here, so this is a horizontal plane now. So you can see 3 points x, y, and z. So they are all on the plane. So let's start the location now. So the start, it says the bearing of y from x. So where you are coming from, I've told you before, is very important in bearing. So it is where you are coming from, you draw first on your paper. So let's start with the bearing of y from x. So let's start with point x. So let's go to our paper. You get your pen. So let me start somewhere here. I have my straight line. You can just make a sketch. You can use your ruler to make your work very neat. I'm just trying to make a rough sketch. I want us to understand it very well. That's why I'm doing this. So we are starting from x. So let me label my x. So this is my point S. You remember the basic assumption, I'm facing north. So you are always facing north in bearing. So this is where I'm facing north, and this is 0 degrees. So let's see the bearing now. It says from x is 312. So let's go and sketch it in the question now. So you start from 0, you turn your 90 degrees, you keep going to south 180 degrees, you keep going to west 270. So you know we are targeting 312. So this is 270. So 312 is going to be somewhere here. So you come and you sketch. You know I'm drawing without scale, so that's what I'm doing here. So this angle is 312 degrees. So take note of that. Alright, now where are we going to? We are moving to point Y. So you draw your point Y, locate your 4 cardinal points. So this is point Y. You must label it, very, very important. And you are also facing north. I've told you in bearing you are always facing north. Take note of that. So from x down to y, the bearing, which is the angular turn, is 312 before you move straight to point Y. Alright, let's go back to the question. So we have settled the first part from x to y. We have located that bearing, which is that. Then it now said, and of y from z. So there's also another point z. When we move from z to y, our bearing is 22. So from z, so I need to locate a point called point z. So if z is going to be 22 degrees, that means z cannot be on this place. You get what I'm saying? If I put, let's say for example, I put my z here. So, and I want to move from z. I want to move from z to y. So it's not possible for 22 to be here. You know 22 is between 0 and 90. So 22 is supposed to be somewhere here. So 22 should go like this. So it's not possible for z to be on this place. So that, and z cannot also be on this place. You must understand all these principles in bearing. Z cannot be on this place because when you turn, you see, we said 22. 22 should be from 0 to 90. 22 should be somewhere here. So the only place I can locate Z is to put it somewhere here. This is the only place I can get my value for Z. So if let me just assume somewhere here. You know we are not drawing to scale. That's why I'm doing it like this. Because in exam you may decide to solve without drawing to scale. So that's why I'm doing it like this. So you label it point Z, 22 degrees. That means you turn 22 can be somewhere here because you are not getting up to 90. This is 90. 22, then you draw straight line down to point Z. So this is Z to Y, so down to point 1. So let me erase this one that I don't need. Alright, so that one is gone. So my triangle is set X, Y, Z, and remember this angle is 22 degrees. Don't forget. So from Z down to Y, the angular turn is 22 degrees, which is this, and that of Y from Z. So from Z down to Y is 22 degrees. So we have settled all that. You can see that bearing is not actually difficult. If you know how to locate your point, how to do your turning, the next thing to know how to do is your calculation for length, and that is what this question requires. You should be able to know which of the theorem to apply. Is this Pythagoras theorem? Is it a trigonometric ratio? Is this sine rule or cosine rule? Then you know what to do next. So this one, and they gave us some length. They said xy is 32, then yz is 50. So xy is 32, so xy, so this place is 32, then 32 kilometer. Then you have your zy as 50 kilometer. So this is 50 kilometer. Alright, so by getting this, our question is over. The next thing is for us to join this point Z, join it to this place, to point y, x. So this is x, y. You can see, because I just did this thing on a rough sketch, so this east line I put here is like this is directly east. This is just a rough sketch, so you always make your sketch neat using your ruler and your pencil. But I will still make a good calculation, a good sketch. But I just wanted to understand the format of bearing, because there are some questions that will tell you to give a sketch of your question. So this is how the drawing is. Make sure you use your ruler and your pencil. Make your work neat and okay. You don't necessarily need to draw to scale, except the question requires you to draw to scale. So take note of that. So now what are we calculating? Let's see. It said we should calculate to one decimal place. Number one, xz. So which is here xz. So that is this distance from here to here, xz. So if I call this distance, let me call it g. Let me just call it g. So if I call xz d, this distance, so what am I going to do? So the only way I can get this xz, I need to know this angle here. I need to know this angle. This is the only angle that is assured in this question. So if I can get this angle, then we can use our cosine rule to complete this work. So how do I get this angle? I know this turning from here down to this place is 312. So I can get this small angle here. You understand? Because if 312 goes like this, and if the full angle is 360, so 360 minus 312 will give us this small angle here. So that one we settle that, which is 360 minus 312, and that is 48. So that means this angle here is 48 degrees. Take note of that. Just wanted to see how we solve bearing. So if this is 48, remember what I told you, this is north, this is also north, so these are parallel lines. So alternate angle 48 is going to be equal to this place. So this place is going to be 48 also. Take note of that. So this is 48 degrees. Then what about this angle here? We need to get it from here. So this is also north. You know, this is also north. So north and north, you can see these are two parallel lines. So this is 22. So this place is alternate to the other angle, 22 degrees. So now that you know both angles, 22 degrees alternate to this side, 22 degrees, 48 degrees alternate to this side, 48 degrees. So 22 plus 48 will give us the full angle here. And by knowing this full angle, we are good to go. I can use my cosine rule to solve this question. And finally, 22 plus 48 is going to give us angle 70. Yes. So this place is going to be 70 degrees. So now that I know my 70 degree, my G can be found easily. All I just need to do to get my angle G is to use cosine rule. And what is cosine rule talking about? Cosine rule is just talking about the side facing the angle. You need to square it first. So D is facing 70, so I need to square my D first. So that is the first rule for cosine rule. So cosine rule now. So let me write it out using cosine rule. So using cosine rule, so you square the D, which is the side facing the angle you are looking for. So D square is going to be equals to, that is this. So this D is facing this angle, so you square the D first, then equals to, you square the other two sides and sum them. So it's going to be like this: 50 square plus 32 square. Then you subtract now. You subtract 2 times 50 times 32, then times cosine of that angle that is facing the D, which is 70 is the angle facing D. So you find the cosine of this angle 70. So take note of that. Maybe one of my videos I'm going to explain cosine rule so that you understand it very well. But you can revise cosine rule from any good mathematics textbook. So the side facing the angle you want to calculate, so you square that side, equals to, you square the other two sides and sum them, then minus 2 times 50 times 32 times cosine of the angle facing the side. So that is all about cosine rule. The next thing is for you to solve down with your calculator and you finish it. So that is D square so this square is now going to give us let me use my calculator to simplify this further. So I'm going to get this, let me just do it once in this place, which is 50 square plus 32 square, 32 square minus 2 times 50 times 32 times cosine, let's get our cos, times cosine 70 degrees. So everything you can see, the answer is 2429.5. Let me take it to 2 decimal, 54. So 2429.54. So let me check to confirm the result again. 2429.54. Okay, 2429.54. Then finally, to get my distance, which is an xz, I need to square root the other side, which is d is going to be equal to square root of 2429.54, and that is going to be what now? So d is going to be equals to, so let me just simplify it here, it won't take me time here, 2429.54. So the answer is 49.29. 49.229 kilometer. So that is the distance. So that is the distance xz. So in the diagram you can see it, the distance xz, which is from here to here, is 49.29. The question says we should take it to 1 decimal place, which is going to be That is going to be 49.3. So to one decimal, d is equals to 49.3 kilometer. So that is all with this first part of the question. So if you look at the second part says we should find the bearing of z from x. So that means from x, if I'm coming from x to z, what is going to be my bearing? So we are talking about this angular turning. If I turn all around like this, down to this line, so what is this angle before I will move down to z? So the only way we can get this angle, this angular turn, is to first of all get this angle here. So the angle that connects x to z, I need to calculate it first. Sorry, the angle between this line that connects xz and this line xzy. So if I can get this angle, then it will be easy for me to trace that. Remember, I did this thing on a rough sketch, so I can't really say if this line is on the east line. So until I solve my theta, let me see the value of theta first. If I add theta to 22 and my result is less than 90, that means x, the actual position for x, is going to be up here. No, I just did a rough sketch. But if my answer of 22 plus theta is giving me answer greater than 90, that means x is supposed to be somewhere here. That's what it means. So by doing that, we can easily do our bearing from x to z. We can get, it's not a difficult thing. So let's get theta. So how do we get theta? So I can also use my cosine rule, as I explained the other time, or I can also use sine rule. Since I know d now, I can use sine rule, I can use cosine rule. So anyone will work for us to get our result. But the one that will be faster for us is sine rule. Since I know my 3 lengths and I know this angle here, 70 degrees, so it will be easy to use sine rule. And what is sine rule talking about? It's talking about the side facing the angle. You divide it, so it's just a ratio of this side to the sine of the angle facing this side is going to be equals to this side 32 and the sine of the angle facing it. That is it. So how do I get that now? So in order to get that, I can just do d divided by sine 70, and I've calculated my d now. Let me do it on this side. So d is that. Let me put the rule I'm using. So using sine rule. So using sine rule, we are going to get so d is 49.29. So 49.29 divided by sine of the angle facing it. So this is the length, 49.29 divided by sine of the angle facing it, which is sine 70, and it's going to be equals to then the other length is length 32 divided by sine of the angle facing 32. So and that is going to be 32 divided by sine of the angle facing it, and that is the angle we don't know, which is angle theta. So all we need to do now here is to cross multiply and find the arc sine of sine theta here. So that means I'm going to have sine theta is going to be equals to, so when you cross multiply and simplify your equation very well, it's going to be 32 times sine 70 divided by 49.29. So let me simplify this in my calculator. So 32 times sine 70, so that is 30.07. So I'm going to divide 30.07 divided by, what's my value there, divided by 49.29 divided by 49.29. Okay, that is 0.61. So what I have here is sine theta is equals to 0.6101. If I take it to 4 decimal places, so therefore my angle, which is the theta now, so therefore theta is going to be equals to, you find this arc sine, the sine inverse. So the sine inverse of 0.6101. So that is going to be what? Let's just go down a little. Okay, so that is theta is going to be equals to, so the arc sine of this is going to be what? Let me do it with my calculator. So that is this of 0.6101. So it's going to be equals to 37.5, let's say 37.6. If I take it to 2 decimal, 37.6. So it's giving us 37.6. So that is this angle here. So now that this angle is 37.6, let me add it to 22. If my answer is less than 90, that means x is supposed to be somewhere here. This bearing from x now to z is supposed to go straight like this to somewhere here, not downward like this. Understand what I'm saying? This is one thing one need to understand about bearing. Most students always confused about this area, so you need to get it very well. You need to understand what you're actually doing. Remember, north and east supposed to be 90 degrees. So I'm getting an answer that is less than 90, then you know what to do. So let's add this. So if I add my 37.6, if I add it to 22, what do I get? I got 59.6. So that means it's less than 90. So you get what I'm saying? So 59.6 is that. So that means from here, the turning, when you are moving from x now to z, let me just get a sketch to demonstrate it here. Let's demonstrate it here again. Let me move up a little. If I have something like this, this is what I'm saying. You can also put this in your solution page so that you get what I'm saying. That means x is going to be above, not below. So that's what we are saying. And this place, when I added it, 22 plus 37.6 that I got there, remember I got 59 point something, so it's going to go like this. Remember, this is x. So this turning here is 22. Let me check it again. So 37.6 plus 22, 37.6 plus 22, so we got 59.6. so this angle here is 59.6. so if this is 59.6, then what will now be this bearing now? So this is what the question says we should calculate. So you know how we are doing it. So this is 180 plus what? And remember the secret I've already told you. This is the north line. This is also the north line. That means 59.6 is alternate to this angle. So this angle is 59.6. So this is 59.6. So you can see it. So all I just need to do is to add 59.6 plus 180. So that will be the bearing of x from x to z, and that is the end of this calculation. So finally, you can just put the statement that therefore the bearing of z from x is this value we got here, which is 59. Let me just add everything so that we can understand it better. This 22 plus this angle here, so it's going to be like this. That is 22 Okay, I've added it. I'm sorry. I've already added it, so which is this 59.6. So you understand what I'm doing. So that means we have 59.6 plus 108, and that is going to give us what? 59.6 plus 180 degrees, and that is 239.6, and that is going to be equals to 239.6 degrees. So this is the final answer to this question that we just solved, which is WAEC. Let me see, that is WAEC 2006 number 13B. So the distance XZ is 49.3 kilometer, and the bearing of Z from X is 239.6 degrees. So that is all with this question. You can go through the diagram again, you understand everything. Just go through the video very well. You see that it's not really difficult, it's easy. So before I go, let me solve this same question using a scale drawing. Let me use this GeoGebra to solve it. Let's just confirm our answers, so that by watching what I'm going to do in GeoGebra, you are going to understand this question more better. So I have my 3 points X, Y, and Z. Let me follow the statement and put everything there. Let me get the statement again. So it says we have 3 points X, Y, Z. So from X to Y is 312. Let me put that one there. So from X to Y now. So let me just turn my turning. Just watch my turning here. So 312, so which is this. So I've already turned it. So X is already turned. So I'm moving from X to Z at that point, 312. So, and what is the length? Let me see the length, 32. Okay, let me, because of the size of the screen, let me take a scale of 2 centimeters to 1 kilometer. So let me divide 32 by 2. I'll use 16. So my final answer, I'm going to multiply it by 2. So let me use 16 there. So that means if I connect from X down to Y, I pull my length. So if I pull my length, let me put 16 here. Yeah. Okay, let me move it gently. Okay. Okay. Alright, so this is 16. So let me move this out. So this is X. So I think we are okay. So they may have some little approximation, but just take note of that. So the turning is 312. Then let's go to the next part. It said from Z to Y now. So coming from Z, we turn 22 degrees. So let me turn. So this is Z. So just watch as I move. So I move 22. Let me move my Z to this side. So this is my angle. Let me put it here. So we said 22. So that is 22. So if I connect with my line, so from Z to this point, and the distance, let me check the distance. The distance here is YZ is 50 kilometers. So remember, I'm dividing by 2, so I'm going to use 25 there. So let me get my length. So I need the length of 25. Sorry, I need to. Okay. So I need the length of 25. Okay. We move it up, so now balance it. So 24, 25. So let me position it well. So I've not really targeted it. Let me balance it well. Okay, so I've really gotten it now. Alright, so I've gotten it now. So that is it. So 16, I divided this side by 2, 32, I divided by 2, 25, I divided by 2. So with this, you see our answers is going to come out clearly. So that means if I connect my z to x, remember the answer we got, z to x, which is xz, we got 49.3. So if I connect it now, if I find this length, it's going to give me that. So if I times this by 2, 24.12, I'm going to get 49.3, at least approximately the answer. Remember, I divided by 2, so I'm going to times by 2 to get that. So 24.12, I times it by 2, 24.12 times 2. So you can see just an approximated value. So though we have 49.3, this is giving us 48.3. It's just the setting. I think if I do some setting here, I will get that value. Let me set it. Okay, I think I've positioned it. The arrow is really pointing towards y. This is 16, so it has increased to 24.3. So let me set it 24.3. So though it's still close, there's no problem. It's just an approximate value. You know, this is a scale drawing. Take note of that. But you can see our answer is very close, which is 48.6. Take note of that. Then the angle we got the bearing from x going to z. The turning we got 239.6. Let's check it and see what we are going to get. So that means if I go back to 0, if I turn from here down to this place, I'm supposed to get 239.6, at least an approximate result. So just watch as I turn. Be watching this place. So be watching it here. So I'm going down till I get to this place. Supposed to be 239.6. So we are very close. 35, 36, 37, 38. You can see it very close. So at least we are still in order. 239. You can see the turning from x down to this point before you move to z. So when you use your scale drawing, you get the same result. So this is all I want you to get for now. So I hope you understand this question that we just did, which is a WAEC 2006 number 13B. Is a theory question. So take your time, go through the video very well and carefully, and follow all the sketches. Make sure you sketch it out on your paper, calculate it very well with your calculator, and you see that the question is really easy. It's not a difficult one. So thank you for